Hello, this is Andrew with WMH Racing, and today I am going to introduce the new Rotor Master V2. There are a few differences between the V1 and the V2 Rotor Master. The first difference is the V2 is designed with reverse polarity in mind, so you can plug in the leads negative to the positive and positive to the negative, plug it into your power source with the positive on the positive and negative on the negative, essentially giving reverse polarity to the unit, and nothing happens. No turn on, no smoky, no nothing. And just to prove that this battery is not just a dud, we'll flip this over, put the actual positive where it goes, negative where it goes, and then plug it in and watch it power up. Alright, so that is the first difference. The second difference, obviously, is I am not soldering the wires to the board anymore. I'm putting 3.5 female bullets in there, and then I will provide the pigtail and an XT60, but you can switch that out for 4mm bullets if you want to put it into your power supply, because this does work with up to 15 volts. So I think the minimum voltage required to run it is 7.2-ish, around 7.2 to 15 volts is the operating voltage of this unit. And it doesn't matter if you're running this off 7.2 or 15 volts. The reading's still going to be extremely close. Alright, so there's one difference. Another difference is I've gone ahead and redesigned the holder just a little bit more again, and basically attached it to the circuit board a little bit better, to try and do away with some of the issue that people were having where they would push down on it and it would cause the readings to go up too much. So if we take this rotor and we move around at the maximum of 1772 and I push down on it, I'm pushing down on it really hard to get it to 1677. So it's not, and as soon as I let back up, it's back to it's back to 16. Oh, that's on the north side. It was on the south side, 1673. So it's a much more robust, and you don't have to worry about pressing down and distorting your readings. All right, so there's that. Another thing I've done is I've optimized the startup code to allow for an offset calibration of the sensors. So every time you plug it in and restart it, it will do a calibration offset, which mind you, if you happen to have a rotor on there when you plug it in, it's going to offset it based on the rotor that you have in there. So when you take the rotor off, now you're going to have false readings. So you're going to have to unplug it and plug it back in without the rotor. The reason why I did not have this done on the first version is because I had the reset data pin tied to the reset button on the actual controller, which meant that resetting the data would have calibrated again, and it would calibrate it with the rotor on there. So I try to make it so it was easier. So you hit to reset the data and it wasn't recalibrating. So now though, because people wanted a faster reset pin, they didn't like waiting 2 seconds for the screen to reset. So because they wanted a faster reset pin, I just tied the original reset to a to a digital pin, and now to actually reset the whole board, you have to turn it off and turn it back on. But I can sit here and I can hold down the reset pin. You can see the values just go straight to 0. As soon as I let go, you get your max reading again. Also, all right, so I covered the reset pin. I covered that. I covered that. Oh, another cool thing, actually. The Rotor Master V1 came in this nice black little cardboard box. The V2 comes in a nice EVA protective case. It fits in there extremely well. And I think it's a bit nicer than the cardboard box. Another difference between the V1 and the V2 is the actual measuring capabilities of the V2. So the V1 could get to a maximum of about 1900 gauss. I thought that was high enough. I really thought that 1900 gauss, who was going to need to go over 1900 gauss? Come to find out, there are these things called outlaw rotors, like this one. And this rotor is a 13.5 millimeter rotor. And the gauze on it is actually insane. So I guess they run these in like 13.5 drag racing. Well, regardless, we're going to see here that this rotor is measuring almost 3,000 gauss. 2270. And 22, slide it over a little bit more, 2290, 2293, yeah. So, you know, crazy rotor. Now, a 13.5 millimeter diameter rotor is going to read slightly higher than what it really is, because it puts it a millimeter closer to the board. And if you take a rotor and you put it closer to the board, it will read a higher number because of that. And here I'm going to go into a couple of things. I'm going to go ahead and test a couple of rotors for you guys. One I'm going to test is the, this is an R1, came out of a 21.5 V21S. This is a hand-picked stator and hand-picked sensor. But R1 does not handpick your rotors. They don't give you the option of buying rotors with better values on them. And I've always found that R1 rotors are actually a bit weak. Their motors are great. And even though this rotor is a bit weak, it still has those motors still have a lot of torque. And they're really great really great motors. But mainly what you're looking to do with this is check your motor when you get them new. See how they compare after you've used them, see when it's time to replace your rotor. So it's not always necessarily the case that a super strong rotor is what you're after. So, you know, like I said, here's the R1, measures 1681 on the North Pole and 1669 on the South Pole. So any of you guys don't realize this, but the values on the right side are essentially just the maximum value read of that side of the rotor that's being measured. So right now I'm measuring the South Pole of the rotor, and the maximum value read is 1669. If I flip this over, you see the North Pole is being read, and the maximum value is 1681. All right. I will tell you also that the three sensors that are in there, the idea is to align the rotor in the magnetic field between the first and the third sensor to try to get the middle reading, because this is where I calibrate the middle reading to, is the first and the third sensor being essentially close to each other. You can move it up, you can move it a bit. Let's see if we find 1669, and we move this rotor a bit, and you can see that it's still staying pretty much right around 1669. So there is a bit of leeway there. It's not set hard in stone. It's just the middle point is where I do the actual calibration. Now, having the first and the third sensors are also nice because you can actually see how far the strength is off of the center of the rotor. However, I do use only the one calibration value And so the first and the third sensors can differ slightly between different boards because these are all hand soldered on, and they could be, you know, a couple tenths of a millimeter off, and they will give slightly different readings. So this is mainly, again, just for measuring on the device that you have to get those readings and how they differ on your rotors, to see how well the strength is, you know, a little bit off center. All right, next rotor I am going to measure is a hobby wing. Now, hobby wing, they just got to be different. I don't know why they got to be different, but they got to be different. So hobby wing shafts. One of the problems is this big, on the output shaft, they have this part that is, you know, 5 millimeters instead of the 3.17 millimeters. And so that extends out a little bit, and then it drops to 3.17. So you have to be careful. I've had to redesign the distance between the two stands of the rotor holder a couple of times to try to make sure that all motors fit in there. Now, the most annoying part about the hobby wing rotors that I have found is the output shaft on the rear of the rotor is actually only 3 millimeters instead of 3.17 millimeters. So the front, this shaft has to be 1/8 of an inch to fit, you know, all the pinions that are out there. But Hobby Wing decided to make this part 3 millimeters instead of 3.17. Now at 3 millimeters, it can drop down into the rotor holder just a little bit far and give some inflated readings. So to measure a Hobby Wing rotor and get better results, let's see if you can actually see. But what I've done is I've actually put one layer of clear tape, just regular tape, on the rotor shaft. I will have to take that off before I put it back in the motor, as you will see, it's not going to fit into the bearing with one layer of tape. It does not fit into the bearing. But when I put it on here and scoot it all the way over for measuring, I get more realistic values out of this at 1740 and minus 1739 on the north side and 1750 on the south side. And again, this is still seems to be the best instrument for measuring Hobby Wing rotors. All right, so to go back over the differences, the new one will measure up to 4,000 gauss. It comes in a nice black EVA protective case. I have finalized the actual case design. I like the protective border around the OLED display. We now have 3.5 millimeter bullet connectors to connect to instead of the wires being directly soldered to the board. We have an offset calibration that happens during the startup. We have an instant data reset pin. And I have stabilized even further the rotor holders. With all these changes that I've made, I felt it was time for a V2. And this is it. This, as far as it's concerned, is for this product, I'm finished with the V2. I will at some point in the future, a year or 2 years, I have no idea. I'm going to release a completely different version, but this is it as far as like simple, easy to use, get your values, record them and be through with it. Whatever I release in the future is not going to be based on this platform. All right, and a word about the V1 Rotor Masters. I do still have some boards left to make the V1s. I sold my last white PCB 1 day ago, and that is shipping out. That's actually in the mail and shipping out to the customer right now. I have in stock 11 circuit boards left for the V1s, and that's it. That's all. I have them in stock. You are only going to be able to get the V1s from my website. Well, Rotoron has a few. Rotoron does have my very first version. He does have those in stock at his store, but for the rest of them, for you want to choose your color case. Yeah, I have 11 V1s left in stock. That's all. I'm not going to stock the V1s anymore after they're sold out. The V2s also only come in a white and a black PCB board. And I think I said this, but the V1s, I only have the black PCBs left. So the V2s are just going to be the white and the black. The other colors were not as popular, and I decided that if the demand is there, I will order some of the other colors. But I will have to get lots of requests for the other color PCBs before I actually order them. And I think that is all. So as always, you can get all my products at www.wmhracing.com. And you can get most of my products at drcproshop.com. Thanks.